Hello, good morning, good afternoon, good evening to everyone. Welcome back to our online tutorial. This is your host again, James Yela, or popularly known as SOT. We'll pick it up from where we ended from last time. I believe to those who watched through the previous tutorials, we've been looking at SADs, and I believe that 3/4 of you went through the tutorial videos and understood the concept regarding SADs and radicals. So today we'll take it up from there, where we'll be talking about the concept known as rationalization. So we'll be talking about the concept known as rationalization. So once you have an idea or the concept related to SADs, you have to now build it up from there, where we can now talk about rationalization, where you'll be able to rationalize a number of fractions which will be given to you. So basically, I know there are a number of questions running through our minds right now, where we have to understand what kind of an animal rationalization is and so forth. So now we understand what a radical is, we understand what a SAD is. So now I want you to understand that there are some cases whereby you've been given fractions which comprises of SADs in it. A SAD can either be in the numerator or a SAD can either be in the denominator. So most of the times mathematically we are trying by all means to make the fraction be free from SADs. That SAD can be, maybe you can try to express a fraction to be free from a radical which can be in the denominator, or free from a radical which can be in the denominator or numerator, either of the two. So basically what we're trying to say here is that if I know we have a number of us who love watching while it's writing, so we can be able to write down some of the points which can be necessary to help us understand fully. So we're being taught to say if a fraction has a number with SADs, if a fraction has a number with SADs in either the numerator or denominator, so we're simply saying that if a fraction has a number with SADs in either the numerator or denominator, we are able, or we can remove the SAD. So we can remove the SAD from either of the two. So that's the basic concept we're supposed to understand under rationalization. So what we're trying to simply say here is that we are able to remove this SAD from either this numerator or the denominator by simply just multiplying the fraction by a special one. So understand what this special one is, how this special one is made up. So we want to make either the numerator or the denominator to be free from a SAD, to be free from a radical. So once you remove that SAD or radical from the numerator, we simply say that the fraction is rationalized. So if you remove the sad from the numerator, we are simply saying that we have rationalized the numerator. If you remove the sad from the denominator, we are simply saying that you have rationalized the denominator. So basically what we're trying to simply say is that rationalization involves making a fraction be free from radicals or sads. So if you want to make a fraction to be free from radicals or sad, what we're trying to do basically there is the rationalization. And how is this rationalization done? Is being done by multiplying through this fraction by a special one. So we're going to multiply this fraction by a certain special one. This one is very special. Yeah. So let's look at examples. We can now dive into examples. So some of the examples here we can simply say, remember we're talking about two things here, a fraction as a numerator and a denominator. This side can be in the numerator or this side can be in the denominator. So sometimes questions will specify to tell you to say rationalize the numerator, or other questions will simply specify to tell you to say rationalize the denominator. So that is the basic concept you're supposed to be able to understand there. What are you rationalizing? Are you rationalizing the numerator or are you rationalizing the denominator? So if you are rationalizing the numerator, it means that you are trying by all means to make the numerator be free from a radical or a sad. If you are rationalizing the denominator, you're trying to by all means to make the denominator be free from sads or radicals. So our first example or our first question will be rationalize the denominator of the following. So we're going to rationalize the denominator of the following. The first one will be 1 over root 2. The second one will be 1 plus root 2 over 1 minus root 2. That's the second one. And the third one we're going to have is we can have root 20 minus root 5 plus root 18 over 1 minus root 48. So these are the three questions we're going to rationalize in our first example. So what are we doing here? We want to rationalize the denominator. Now, if you look at, pay particular attention to these three expressions. What is happening here is that there are some expressions which have sads on both cases. In the denominator as well as in the numerator, there is a sad. In the numerator and the denominator, there are sads in there. So what are we doing? We want to try to make sure we obey the rule of the question. The rule of the question simply says rationalize the denominator. So our emphasis or our focus here is that, what is our focus? Our focus is to make the denominator free from a radical or a sad. Want to make the denominator free, be free from a radical or be free from a sad. So that is our focus in this question. We don't care if the numerator can have a radical at the end, but our focus is to make sure that the denominator is free from a radical. How do we rationalize? We Remember the first point we wrote, how do we rationalize? We rationalize by multiplying the fraction by a special one. We rationalize the fraction by multiplying this fraction with a special one. What does this mean? This means that whatsoever you multiply to the denominator is supposed to be multiplied to the numerator. Hope you'll be able to get the concept. Yeah. So what are we saying here? So let's start with the first one. So this one says that we're going to rationalize the first one, and this is the simplest, 1 over root 2. We want to rationalize this expression. We want to rationalize it, and the only way we can rationalize this guy, or rationalizing the denominator, remember the denominator has a radical there, has a side. We want to make the denominator be free from a side. How do I handle it? I'm supposed to multiply. We shall multiply by a special one. By a special one. So now, how is this special one made? How does this special one come about? What are you rationalizing? You're rationalizing the denominator. It means that you're supposed to get rid of this radical in the denominator. Get rid of it. Make the denominator free from a radical. Now, I'm trying to bring in concepts of sides here. Remember, we did some properties on how to do operations on some of the sides. What can you do for this denominator to be free from a radical? In short, you want to delete this radical here. And the only way you can delete this radical, remember that property we simply said, the only way a radical can be deleted, we are going to use the property, remember the property, root of a multiplied by root of a. If I multiply these two, what will happen? I'll just end up with the a. Remember, root of a multiplied by root of a, these two will cancel each other, and I'm just going to remain with the a. This is where the special one is coming about. Investigate what you're deleting. This is root of 2. And the only way for this radical to be deleted, it is to multiply according to this property. So I need to multiply the denominator according to this property. So now, this means that I'm going to have 1 over root 2. So the denominator should be multiplied by root 2. The denominator will be multiplied by root 2. Remember, root 2 multiplied by root 2, I'm just going to have a 2. It means that the radical has been deleted here on this case. But whatsoever you do to the denominator is supposed to be done also to the numerator. So whatever you do to this guy, you do it to the numerator part. So that is where the special one is coming about. So multiplying this whole fraction by root 2 over root 2. Root 2 over root 2, this is just basically a 1. 2 divided by root 2. Root 2 divided by root 2 is just basically a 1. So this is why we're getting the concept. So can you multiply this fraction by a certain special one? We are calling it special because it is not just any kind of one. You are supposed to be able to analyze and think, how can I come up with this special one? Whatsoever you do to the denominator, you do to the numerator. It is the same number. Whatever you multiply to the denominator, you multiply it through again to the numerator. Hence, it becomes a fraction of root 2 over root 2, making us just have what? A 1. So basically, what am I having here? This guy here is what we are calling to be what? A special one. This is our special one. Such that we are simply saying that we are going to have 1 root 2 multiplied by root 2 over root 2. Remember, our aim is being achieved. Root 2 multiplied by root 2, we are going to just have a 2. So basically, this is just multiplication of fractions. You can multiply throughout fractions, this times that, I'm going to have 1 times root 2, I will still have root 2 over root 2 multiplied by root 2, and this will give me root 2 over root 2 multiplied by root 2 according to this property. According to the property root a multiplied by root a, this is equal to a. Remember this in the previous video. If you've not done SADs, I will advise you, before you look at this video, better you go back to the video on SADs. Understand the SADs, then come back to the video or concept of rationalization. So this is a property which we talked about in the previous video, to say root 2 multiplied by root a multiplied by root a will just basically give us an a. These two radicals will cancel out each other. So this is what is happening here. Root 2 multiplied by root 2, what we are just going to have is a 2, and this is our answer. Remember, we are rationalizing the denominator, meaning that we are making the denominator to be free from a radical. Hence, the denominator is free from a radical. This means that our expression is what? Rationalized. Our expression is what? Rationalized. So this is the simplest rationalization question you can be given. Basically, when it comes to rationalization, you're just being taught to make the denominator be free from a radical or a SAD. If you're rationalizing the numerator, you're trying to make the numerator free from a SAD. Here, the question and our first example is talking about rationalizing the denominator. So hence this expression has been rationalized. The denominator here has been rationalized. We don't care about the numerator because our question said that rationalize the what? The denominator. And my denominator is free from a radical. It's free from a radical. Let's look at the second question. The second question says, rationalize 1 plus root 2 over 1 minus root 2. We want to rationalize this one. Rationalize 1 root 2 we're rationalizing 1 plus root 2 over 1 minus root 2. How do we rationalize this one? Remember, we are rationalizing the what? We are rationalizing the denominator. That's what you're supposed to put in mind. We are rationalizing the denominator here. Both the numerator and the denominator have radicals, but here what we are trying to rationalize is the denominator. Meaning, our denominator should not have a radical. Our denominator should not have a radical. Or, in simple terms, our denominator should not have a SAD. That's the concept we're supposed to be able to have here. Our denominator should not have a SAD. Now, 1 minus root 2. 1 minus root 2. This number here in the denominator, the whole lot of this is a SAD. The whole lot of this is a SAD. We don't want to have this SAD in the denominator. Hence, what do? We have to delete it. Now, you have to be very strategic in terms of deleting this. You have to think, how can I delete this radical? You don't want this radical to be there. So if you want to delete a radical in such an expression which is in this format, this is where we are trying to simply embrace in the concept by multiplying through by a conjugate. So I can write maybe that point down, not rationalizing a minus root of b, we multiply by its conjugate. What is the conjugate of this guy? If the expression is a minus root of b, then its conjugate is basically a plus root of b. Or maybe if it's root of a minus root of b, its conjugate is root of a plus root of b. Hope we are getting the sense out of it. So basically what is happening here is that the only way the radicals can be deleted, it is to multiply by its conjugate. So if you have such an expression where two terms are being separated, you have two terms with either minus or positive, negative or positive being separating these two terms, we are going to multiply that expression by its conjugate. So the conjugate of a minus root of b is basically a plus root of b. What is just different is the symbol or the sign in between. If this is a minus root of b, its conjugate will be a plus root of b. If this is root a minus root b, its conjugate is root a plus root b. So this is the conjugate of that, and the same thing is also the conjugate of the other. So these two are basically conjugates. So this is the concept we're going to embrace when it comes to rationalizing of such expressions. So if you have such an expression, remember this expression is different from the previous one. Here we just had root 2, and basically for me to delete the root, I'll just multiply it by the same root 2 and the radical will be deleted. But in this case, it is somehow different. It is not just root 2 alone, but it is 1 minus root 2. And the only way this can be simplified to make the denominator free from this radical, it is to multiply this guy by its conjugate. What is the conjugate of this guy? It will be 1 plus root 2. Okay? That will be 1 plus root 2. So, let me rewrite the question. The question says 1 plus root 2 over 1 minus root 2. So what do? We're going to multiply through by the conjugate of this. So I'm going to say multiplied by 1. What is the conjugate of 1 minus root 2? The conjugate of 1 minus root 2, the conjugate is 1 plus root 2. The conjugate here is 1 plus root 2, which is the conjugate of 1 minus root 2. Whatsoever you do to the denominator, you also do to the numerator. So if you multiply the denominator by this guy, it means that even pamurupadia, you multiply by 1 plus root of 2. So you're multiplying by this guy. So now, look at this. What are we having now? We are having 1 plus root 2 over 1 minus root 2 multiplied by 1 plus root 2 over 1 plus root 2. What is this guy? This is 1, this divided by this. This is also a special what? This is also a special 1. This is also a special 1. Because if you divide these two, what you are going to have is just a 1. No wonder here, if you look at this mathematics closely, nothing is changing. It is just the same expression, but we just want to make it be rewritten in the form of a rationalized way, in a rationalized manner. No wonder we're trying to multiply this guy by a special one. Remember, if you multiply something by 1, nothing changes. 2 times 1 is still 2. 4 times 1 is still 4. So, we've multiplied this by 1. It means that we've not changed this, but we're just trying to rewrite it in a special manner, where the denominator has no radical. So, since the denominator has a radical, for this expression to be free from a radical, I'm going to multiply both the numerator and the denominator by this conjugate, by the conjugate of this guy. So now, let's multiply that. So basically, what am I going to have? I'm going to have 1 plus root 2, which is this guy. This times this, which will be 1 plus root 2 over this times that, which is 1 minus root 2, 1 plus root 2. Okay, so now we know what brackets are, so we have to expand through. We don't want the radicals in the denominator, so the only way they will be deleted if this is expanded. So we're going to expand. We are going to expand. So expanding this, we are simply saying 1 times everything and this times everything. So the same properties under sides which we talked about, we have to embrace them here. Don't forget them. So this will be 1 times 1, which will maintain to be a 1. 1 times root 2, it will still be the root 2. Root 2 times 1, it will still positive root 2. And root 2 times root 2, what do we have? This is root 2 and root 2, same numbers inside and the same radical. It means that the radical is deleted. I'm just going to remain with a what? A 2. Hope we are able to understand this property from SADS. No wonder we started with SADS first. So this is my numerator over, how do I handle the denominator? The denominator says 1 times 1, this is a 1, plus 1 times root 2, this is what? Positive root 2. We are done with this one. We go to negative root 2. Make sure mathematics is all about paying particular attention to simple details, those small details, because once you neglect them, you are gone. This is negative root 2. So it is negative root 2 multiplied by 1. This becomes a negative root 2. Negative root 2 plus multiplied by positive root 2. This is negative root 2 times root 2. Remember, negative is positive to be negative. Root 2 times root 2, what am I going to have? I'm going to have a 2. Same number inside the radical and the same radical, mean that the radical will be deleted. I'm going to have a 2. The concept from root a multiplied by root a, which will just give you an a. This is where the concept is coming from. So root 2 will just give me a 2. Negative and this positive is a negative there. Okay, now let's simplify. Like terms together in the numerator, I have a 1 and these 2. These are like terms, meaning that 1 plus 2, what am I going to have? I'm going to have a 3. Plus, this is root 2 and this is root 2. These two are like terms. Just the same as saying you have one plate and another plate. Put the plates together. What are you going to have? You have 2 plates. So you have 1 root 2 and another root 2. 1 root 2 plus another 1 root 2. What are you going to have? You're going to have 2 root 2s. Then this is our numerator. What about in the denominator? Like terms as usual. 1 and this negative 2, they are like. So I'm going to have 1 minus this 2. I'm going to have something like negative 1. Am I correct? If you're so 1 minus a 2, I'm going to have what? Negative 1. And then we have root 2 minus root 2. What are we going to have? This is just basically a 0. So by the end of the night, what do we have? We have 3 plus 2 root 2 over negative 1. Now, this is negative 1 in the denominator. If it is negative 1 in the denominator, what will happen? This negative can now multiply everything per mod. This is just the same as, remember, any number divided by 1 is the same number. So if I have 1 in the new denominator, if you have 4 over 1, it is still maintained to be 4. If you have 6 over 1, it's still maintained to be what? 6. But it is different in a case whereby you have 4 over negative 1. It is not 4, but it is what? Negative 4. Hope you are able to get the point. So this is what is happening here. This divided by, if it was positive 1, this divided by 1, the answer could have just been the numerator. But because of the excess of the negative 1, this means that the answer is going to be negative of the numerator. Therefore, you can break in the negative inside. This will be negative 3 minus 2 root 2 to be our final answer. Hence, rationalized. So, what was our aim here? Our aim is to make sure that that radical which was in the denominator should be eliminated. That sad which was in the denominator here, this sad, it was supposed to be deleted. Hence, we have successfully done our part until we've arrived to our final answer, which is negative 3 minus 2 root 2. This is not in the denominator, it is in the numerator. Hence, rationalized. Okay? Yeah, so that is the concept under rationalization or rationalizing the denominator. Then we have the third one. We have the third one. So the third one says, this is C. We want to rationalize the denominator, which says root 20 minus root 5 plus root 18 over 1 minus root 48. The same concept of what we've just from doing with the previous one is what we're going to do to this one as well. So this time around, we want to make sure that the radical in the denominator is eliminated. The radical in the denominator should be eliminated. And the only way we can do that is to multiply this by a special one. But before we even do that, we can try to simplify things just as we did in SADS. Remember, we are able to simplify the numerator according to SADS, and we are able to simplify the denominator according to SADS properties. We can still handle it the way it is, but we don't want to complicate things. Try by all means to make things simple for yourself first. By doing what? Making the expressions look simple. We're going to try by all means to make the expressions look simple. For example, how can I handle this? This is just the same as writing these into their simplest version. Instead of me dealing with root 20, I can simplify it to something, a simple version, and simplify that as well to a simple version, and simplify that again to the simple version. So basically, if I look at root 20, the way we did the examples in the simplification in SADS, this is the way you're supposed to go about this one. I'm almost tempted to leave this one as a homework or maybe a task so that you can submit, but let's just run it throughout, run it together. So basically, if we have root 20 minus root 5 plus root 18 over 1 minus root 48. So we want to break down into simple versions, then later on we're going to rationalize. What concept are we bringing in? Concept of SADS. It's the concept of SADS. So this is just basically the same as 4 by 5. Remember, in the concept of SADS, minus root 5. This one cannot still maintain the way it is because there's no way you can simplify it further. Plus this one will be what? This will be 9 by what? By 2, I think. 9 by 2, that's 18. Yeah. Over 1 minus 48 broken down into 2 factors. But one should be, remember, that is what I'm trying to emphasize, to say if you did not watch the tutorial on SADS, maybe it will be a little bit challenging on this one. If you've not done SADS, if you've not gone through the video on SADS, go back and look at the video on SADS, and then this will be very simple for you. So we're trying to break down into simplest factors. So breaking them down, the 48, we can break it down to something like 16 by, I think, a 3. 6 times 3, 18, yeah, so 16 by 3. So this is how we're going to break it down. So simplifying it further now, according to the properties of SADS, this is just basically the root of 4, which is a 2, root 5. 4 is a perfect square, so root of 4 is a 2 multiplied by root 5 minus root 5, which is this guy, and then the root of 9 is basically a 3, and we're remaining with root 2 in there, over the same is happening here, 1 minus root of 16 is a 4, and you remain with 3 there. So what am I going to do now? I'm now going to work with this one and rationalize it. It is easy to work with this one than working with the other one. It is easy to work with this one than working with the other one, because this one will now lead us to what? Actually, these two are like terms. 2 root 5s minus 1 root 5. It is 2 spoons minus 1 spoon. What are we going to have? We are just going to remain with 1 spoon. So it is 1 root 5 plus 3 root 2 over 1 minus 4 root 3. So now I was simply saying this is a simple version compared to this one. This one had three terms in the numerator and 2 terms in the denominator, but this one now it has been simplified to 2 terms in the numerator and 2 terms in the denominator, which is easy. If you want, if you're okay, you can still work out with the one which was on top, which had 3 terms in the numerator, and then go ahead and rationalize. Automatically, you know how to rationalize. You multiply both the numerator and the denominator by the conjugate of this. But if you are using this one, you multiply the conjugate. The conjugate of 1 minus root of 48 is just basically 1 plus root of 48 multiplied by this and multiplied by that. But if you are using the simplified version, you are now looking at 1 minus 4 root 3. So what am I going to do? we're going to multiply by the conjugate. What is the conjugate? The conjugate is 1 plus 4 root 3 over 1 plus 4 root 3. This is what we're going to multiply with. This is still a special one. Remember, we simply said if you have such an expression, multiply by the conjugate. If this is minus, its conjugate just becomes a plus. Okay, so multiplying this, multiplying that. So we're now going to multiply the numerator times numerator and denominator times denominator. So this is just basically root 5 plus 3 root 2. So root 5 plus 3 root 2 multiplied by 1 plus 4 root 3 over 1 minus 4 root 3 multiplied by 1 plus 4 root 3. Okay? Now let's break through. Let's break through, then we can try by all means to expand. Let's break through, then we can try by all means to expand. Expanding the numerator, root 5 multiplied by 1, I'm going to have root 5 plus root 5 multiplied by 4 root that. So let me take it step by step. So I'm going to take it root 5 multiplied by 4 root 3. Okay, going to 3 root 2, so I'm going to have plus 3 root 2 multiplied by 1. I'm going to have the same 3 root 2. 3 root 2 multiplied by this guy, I'm going to have positive 3 root 2 multiplied by 4 root 3. Let me use brackets even here so that we can see that okay, there's multiplication happening. That is my numerator. So this is over, what is my denominator? 1 times 1 is still to be a 1. 1 times this guy still to be positive 4 root 3. This times 1 minus 4 root 3. And this times that, it is negative 4 root 3 multiplied by positive 4 root 3. So try by all means to take care of these signs. So this times that, this is negative of 4 root 3 squared. It is 4 root 3 multiplied by 4 root 3. It means that these two are coming twice. It's multiplying by itself. 4 root 3 is multiplying by its fellow 4 root 3. So it's multiplied twice. So no wonder I've indicated it's 4 root 3 squared. Meaning this square is for both the 4 and the root 3 there. So we have to be very careful the way we write expressions mathematically. 4 root 3 squared, in brackets then squared, means that this square is for both the 4 and the root 3 in that manner. Now let's try to sweep everything throughout and simplify everything. The numerator now, I'm going to have root 5 plus, there's multiplication here. So now this is root 5 and this is root 3. Basically what is happening here, properties of sides. So under properties of sides, we had this concept. Under properties of sides, we had the concept which said root A multiplied by root B is the same as root A multiplied by b under that root. So this is the same concept I'm going to use here. No wonder I'm still emphasizing on the video of sides. The previous video we did on sides. Root a multiplied by root b. These two values or these two numbers under the same kind of radical, you can just take them and put them under that radical, multiply them together. So if I have a situation whereby I have 5 root 5 multiplied by root 3, this is 5 times 3 under the radical. So I'm going to have this 4 multiplied by the root of 5 times 3, which is going to be 15, plus this is also what is happening this side. This one will maintain to be 3 root 2 plus 3 root 2, 4 root 3. This means 3 times 4, which is going to give me a what? A 12. The answer multiplied by root of 2 times 3, which is a 6. So the numerator basically will have root of 5 plus 4 root 15 plus 3 root 2 plus 4 times 3, which is 12, multiplied by root 6. That is our numerator. And what about in the denominator? In the denominator we have this one. Do we have any other? No. So 4, I'm going to have 1. 4 root 3 minus 4 root 3, basically this is a what? A 0. So this goes. I'm going to have minus 4 squared is 16. Root of 3 squared, the square and the root will cancel and be ending up to be a 3. So I'm going to have 16 by 3 here. So I'm going to have 1 minus 16 by 3. 1 minus 16 by 3. So by the end of it all, by the end of the night, what am I going to have? I'm going to have root 5 in the numerator plus 4 root 15 plus 3 root 2 plus 12 root 6 over what? 1 minus 16 by 3. 16 by 3 is what? 48. So 48, 1 minus 48, that is negative what? Negative 47. This is your answer. Hence, rationalized. So, what was our aim? Our aim was to make sure that the denominator is free from radicals. Our aim here was to make sure that the denominator is free from radicals. So what was our aim there? Our focus was just looking at, we were basically looking at the denominators. We multiply the conjugate of the denominator. But if the question was simply telling you to rationalize, if the numerator, if the question was simply telling you to say rationalize the numerator, let's have the second example. So we can have rationalize the numerator of the following. So rationalize the numerator. The previous one, we are rationalizing the denominator. The same concept is being applied. The only difference here is that in the previous question 1, we were rationalizing the denominator. And here we'll be rationalizing the what? The numerator. It means that make sure that the numerator should not have a radical. In the previous example, we're making sure that the denominator should not have a radical. For example, you can have a situation whereby you have root of 2. Rationalize this one. Or maybe you can have a situation where you have 1 plus root of 2 over 1 minus root of 2. The same example, but this time around you're rationalizing the numerator. So how do you handle this one? These ones. Same concept, same explanation, same solving. Multiply throughout by a special one. It can either be from conjugates or you have to analyze what are you dealing with. So if we have root of 2 over 2, we want to make sure that the numerator is free from a radical. We're going to multiply by root of 2 over root of 2. Why? Because we know that root 2 times root 2, we're going to end up with what? A 2. Just like that. So this is now going to be root 2 multiplied by root 2. I'm going to have a 2 over 2 root 2. And then this 2 and this 2 can go ahead, and then I'm going to have 1 over root 2 as my answer. Okay? And B, where we want to rationalize 1 plus root of 2 over 1 minus root of 2. What are you rationalizing? You're not rationalizing the denominator, no. You're rationalizing the numerator. So look at the numerator and not the denominator. The numerator is 1 plus root of 2. Then look for the conjugate. The conjugate is what? 1 minus root of 2. Whatsoever you do on top, do it down. 1 minus root of 2. So if that is the case, what is going to happen now? We can break through. We're going to have 1 plus root 2, 1 minus root 2 over 1 minus root 2, 1 minus root 2. Break through. 1 times 1, that's a 1. 1 times this, negative root 2. This times that, that is positive root 2. And this times this, that is negative 2. Over 1 times 1, that's a 1. 1 times this, that's negative root 2. This times that, that is what? Negative root 2. Am I correct? Yes. This times that, that is positive 2. Like terms and simplification, negative root 2 plus root 2. What are you going to have? This is a 0. Then you're just going to end up with 1 minus 2, having it to be negative what? 1. Over 1 plus 2, which is a 3. These are like terms. 1 plus 2, which is a 3. Negative root 2 minus root 2 is basically negative 2 root 2 as your answer. So that is the concept under rationalization. That is the concept under rationalization. So it is either you are rationalizing the numerator or you are rationalizing the denominator. What are you rationalizing? So once you understand what you are rationalizing, you'll be able to do everything correctly. You have to know what a conjugate is for each case. You have to understand what a conjugate is for each case. Just as we simply said, 1 minus root 2, its conjugate is 1 plus root 2, or 1 plus root 2, its conjugate is 1 minus root 2. So understand what is the conjugate before you start multiplying throughout. Yeah. So this is what we had for today. Yeah, so look out for the task which will be sent in your group, and you'll be required to submit to us. So we'll send the task in the WhatsApp group. Look out for it and do as wise to submit, and do as wise as well to inbox and find clarity where you are not clear, and we'll be able to assist. Thank you very much. Blessed afternoon, blessed evening, blessed morning, whatsoever time you'll be watching this video on, and happy Independence actually to everyone. Can't wait to meet all of you as you will be reporting on the 25th of November. I know each and every day we are drawing closer and closer and nearer to the opening day. Yeah, so can't wait to meet every one of you physically. Thank you very much. Good day.